Okay. So as far as I can tell, the problem with this solution is that you don't have a good coordinate system. So if you look at the coordinate system you've chosen, which I'm assuming is this is your y, and this is your x, you don't have a 90-degree angle there. Okay? So I thought, well, maybe instead you thought that your coordinate system was this versus this. Okay, so if you do that, then you can't actually say that this force is equal to this force. Okay, well, why can't you do that? Well, remember that the only way that you can make that assumption, the only way we've been making those assumptions, is if they're in the x and the y direction. And these two forces, friction and drag, if you choose that coordinate system, have component vectors in both the x and y direction. So you can't say necessarily that since the force of friction was 1200, I think that was given in the problem, that translates to the other side. The second thing that it makes more different, or makes more difficult, is that you've got these two forces in the y direction that you're going to have to take into consideration when you figure out what f of n is, f of n of y, since you know f of g. So anyway, that's why I think choosing or separating f of n or choosing this coordinate system, I guess, is probably not a good way to go about the problem.